It's Monday. All right, today we're going to talk about two things. I'm going to go ahead and show you how to graph some piecewise defined functions that have some nonlinear parts. I'm just going to do two examples of that real quick, and then I'm going to show you how to write equations backwards, but only for the linear. So I'm not going to make you write these guys backwards. All right, so let's go ahead and fill in our tables. Again, just split it up into parts, and then write down your numbers. So whatever number I give you, you have to use. So 1 has to go on there. Numbers less than 1, 0, -1, -2. Going over here, a 1 as well. And then numbers that are greater than 1, so 2, 3, 4. Okay, so to do this, this first one is exponential, so make sure you know how to do that. You can just use your calculator or graphing your phone or whatever, but this is 2 to the first. 2 to the first is 2. 2 to the 0 is 1. 2 to the -1 is 1/2. 2 to the -2 is 1/4. So even without a calculator, you probably can graph that pretty easily. And then don't forget, because this guy is less than, he is going to be an open circle at 1, 2. So I'm going to go ahead and do 1, 2, open circle. And then 0 is 1, -1 is 1/2, and 1/4, and then it'd be a 1/8 and a 16th, etc. And it's starting here, so it's going to go to the left. And that's actually going to be an exponential, and it has the asymptote there. All right, so moving on to the second guy. This guy is a quadratic. Hopefully you can see that. And he's actually in vertex form, so he's in the opposite of the inside, same as the outside. So he's actually a 3 and then a -2. Okay, so I'm going to go over to 3, -2. I'm going to put a dot. We know that this quadratic has a 1, 3, 5 pattern. You multiply by the number up front, but there's no number, so it's a 1, 3, 5 pattern. So I'm not going to actually do the math. I'm just going to go up 1 over 1. So that means these will both be at -1, sorry. Then he's going to go up 3. He's going to go up 1, 2, 3. He would actually end up being here at 2. And then if I were to go the other direction, 5 would also be at 2 if I were to do that. So you can see I have my quadratic, but I didn't circle yet. So greater than or equal to 1 means that this guy is going to be a filled in circle. So this actually is going to be filled in. So I'm going to go ahead and just fill that in. And this quadratic is going to be going to the right. He's going away from +1. So he's going to go down and up. Also, this arrow didn't turn out very well. Okay, pretend that actually crosses that line. But this is a piecewise that has an exponential. It was open, but it picks up at the quadratic, and then it goes on forever. All right, for our last example, we have 3 parts here. Let's go ahead and do the first one, which I can see as a quadratic. It goes from -5 to -1, so I'm just going to go ahead and fill in -5 to -1, and every number in between that makes sense. I'm going to go ahead so I don't forget and box this guy off and circle him. So he does actually have 2 endpoints. So he starts at -5 inclusive, and he ends at -1 not inclusive. All right, well, he's a quadratic, so I'm going to go ahead and find his vertex. So opposite of the inside, same as the outside. -3, +5, and that's really convenient that that's in the middle. So -3, 1, 2, 3, +1, 2, 3, 4. Oh, 1, 2, 3, 4, 5. Okay, and then this has a 1, 3, 5 pattern, but it has a negative number out front. So it's going to be a -1, 3, 5 pattern. So it's going to go this direction, 1 and 1, which means it'll be at 4 and 4. Then it's going to go down 1, 2, 3. And be here. Well, this -5 is going to be closed, so I can go ahead and put that there at 1. But -1 is going to be open at 1. So there's that guy graphed. There are no arrows in this one, so I'm just connecting it. It's not going forever. It's only going from -5 to -1. Okay, the 3 to the x is obviously exponential. It's going from -1 inclusive to 1, so -1 to 1, include whatever you want to, it doesn't really matter. As long as you have the 2 points, that's all that matters. So 3 to the -1 is 1/3. 3 to the 0 is 1, and 3 to the first is 3. I don't even want to do what that number is. I don't really care. So -1 1/3 is going to be inclusive, and 1/3 is going to be open. So -1 1/3 is going to be here, closed circle, 0, 1, and 1, 3. 1, 2, 3, open circle. It's a little small section, but it doesn't matter. And if I did the other number, it'd be in here somewhere. Okay, so no arrows, just going from this portion to that portion. All right, last one is just linear and it's greater than 2. So I'm just going to do 2, 3, 4, 5. And just copying those numbers, so I don't have to do math, are 0, -2, -4, and -6. And this 2 is not inclusive. So just going to go graph those. 2, 0, 2, 0, open circle. 3, -2, -4, and -6 doesn't fit. And then I'm going to the right. This guy does not stop, so he is just going to have an arrow that goes forever. So be able to graph just anything I give you, linear or nonlinear. All right, so changing gears, we're now going to write the equation given the function, which is pretty simple actually. Just make sure you know how many separate parts you have and break it into those parts. So I like to label the parts. So this is the first part, the second part, and the third part. And hopefully you can see that they're actually being separated by these understood up and down lines. Okay. So equation 1, you just have to know, in order to know an equation, you have to know slope and intercept because I'm only giving you linear. So I can see my slope is, just count down and over. It goes down 1, 2 over 1, 2, 3. My slope is -2/3. My intercept is 9. Therefore, my equation is y equals -2/3 x plus 9. If it's one of those ones that crosses the y-axis, it's super duper easy. I already went ahead and just pull it all together. You literally just take each of these equations and fill them in, and then you put the restriction on that domain. So I'm just going to bring this equation down here. You don't write y equals here. It's y equals all of these things. So it's going to be -2/3 x plus 9. And when is that true? Well, that's if x is between 0 and 3. So don't look at these upper numbers. That's where your intercept comes in. It's between 0 and 3. Well, 0 was this open circle, so not inclusive. So 0 less than x. And then it's going to 3 closed circle. And you can actually, because this dot is included in both, you can either include this on this equation or that one. Doesn't matter. So I usually ignore the first one. So I'm actually going to say not 3, and then I'll include 3 on the next one. Okay, so hopefully that makes sense. And we'll do 3 more examples. Hopefully you'll see it. All right, second one, straight lines are even easier. The slope for a straight line is 0. And the intercept is just where it would cross if it kept going. So 7. Your equation is literally just y equals that value. Y equals 0x plus 7 or y equals 7. That's literally it for straight lines. They're the best. And then again, where does this guy start? Well, he's starting at 3 and he's ending at 6. But 3 has to be included somewhere. We did not include it in the first equation, so it has to be included here. And then it's going to stop at 6. You could include 6 here or include it in the next one. I just have the tendency to always exclude it in the first one and include it in the second one or the one after it. All right, the last one is actually a little bit of work. This is about the worst case scenario you'll ever see, is when it's not crossing the y-axis so you can see it. So you got to do a little bit of work. So we still need to find our slope, which we can easily do. So slope is down 1, 2, 3, 4, 5, running 1, 2, 3. So slope is -5/3. Okay, and then you can do, if you wanted to, you could just count up 5 and over 3, up 5 and over 3, and this guy would actually work out pretty nicely for that. Or just pick an ordered pair, and I'll just do it here. Pick an ordered pair, and we'll just do point slope form. I'd rather do that. So ordered pair here would be, I guess, 9 and 2. So 9, 2. All right, I'm just going to take y minus 2 equals -5/3, x minus 9. I just need to get y equals by itself. So I'm just going to say y minus 2 equals -5/3, x plus 15. Okay, and then add that 2 over, you get y equals -5/3 x plus 17. So just take that equation down here, -5/3 x plus 17. And then where's this restriction happen at? Well, it starts at 6 and it ends at 9. There's no arrow in this case. 6 was not included previously, so I do have to include 6 this time around. 9 is inclusive and there's no one else to pick it up, so I have to end with 9. So we're just going to do 3 examples of this. So just find your slope and your intercept. That makes it easy, but the straight line, it's super easy. Worst case scenario, do point slope form and then get it into slope intercept. All right, so here's the next one. I like to go ahead and draw my sections first, and I sometimes like to circle my number if it's not super clear. And there's an arrow there and an arrow there. So I actually have 1, 2, 3 sections here. So 1, 2, and 3. And we're just going to go ahead and do section 1. Section 1 is super easy. Section 1 is a straight line, and it's crossing at -4. So I'm not even going to write out a whole bunch of stuff. I'm just going to write y = -4. Done. Okay. Section 2, this one crosses very nicely, so I can just go ahead and do him also pretty quickly. So the slope is up 1 over 1, up 1 over 1, so it's just 1x, and then it crosses at -2, so -2. If it's crossing the y-axis, it's very easy. Just find your slope and then put on your intercept. Okay, and then section 3, I can see my slope is going down 1, 2 over 1, so it's a -2x. In this one, I actually could just count. So let me show you the counting. So if I'm here at 0 and my slope is 2, I'm going to go up 2 over 1, up 2 over 1. I would actually end up at 4. So I could just say +4. And if you wanted to go ahead and do point slope on that, I promise you it's the exact same answer. I'm only going to do it when I have to. But if I can kind of cheat my way, I will. I will just do slope intercept when it's necessary though. All right, so take these guys. And I'm going to say y equals, big curly bracket, and fill in all of these equations. And then we're going to fill in the restrictions. All right, so this one is starting at -2 and it's going forever to the left. And you do have to decide, do I include this point at -2? And I'm going to say no. So I'm just going to say x is less than -2. Okay, and it picks up exactly at the same point at -2. And then it goes to 2. So this next one is between -2 and 2. Well, because -2 was not included prior, I have to include it here, and then decide, do I want to include 2 or not? And I just usually don't. Okay, the last group starts at 2. Again, we're looking at the x values, and it goes forever to the right. So those x values are greater than or equal to 2. So make sure that you have each number included. So -2 included here, not there. 2 included here and not there. And it doesn't matter if you include 2 here and not there, as long as 2 is included somewhere. Okay, this next one, so I went ahead and separated it in sections, and I went ahead and labeled -1, 1, and 2 so I could easily see it. First section is this guy here. I can see the slope is up 3 over 1, up 3 over 1, so I know it's going to be y equals 3x. And if I just count up 3 over 1, I see it's going to cross at 7. So that's going to be 3x plus 7, and we'll go ahead and do that restriction as well. This is starting at -1, and it goes forever left, and it's included, so x less than or equal to -1. Okay, middle section, straight line, super easy. I'm just going to write him down here. He's going to be y equals 1, 2, 3, 4, 5, 6. And then he is going to be from -1 to 1, but he is not inclusive on either endpoint there. All right. Also, we have a little gap where there's nothing going on, so just skip it. So my third equation is going to be slope is down 1, 2 over 1, 2, 3, so it's -2/3. I'm just going to go ahead and I only have a minute and a half. I can do it. The ordered pair is going to be 2, 6. So I'll show it to you. So y minus 6 equals -2/3 x, x minus 2, y minus 6 equals -2/3 x plus 4/3. Okay, and when you add 6 over, just algebraically, you're going to have the answer here, 22/3. So you get -2/3 x plus 22/3. Sorry for this messiness, but it is what it is. And this guy just skips over the 1 and he starts at 2 and he's going to be inclusive at 2 and then going to go forever to the right. So x is greater than or equal to 2. All right, so I'm at 40 seconds left. I just caught a mistake. I did not mean to put an x there, so just ignore that mistake. Oh well. All right, so this one here has a slope of -7, down 7 over 1, and it has the ordered pair 4, 2. So I just went ahead and did -7 slope and ordered pair there and just did point slope formula. So there's that guy. And you can just pause it if you need to. All right, and that one's starting at -3 and going left forever, so x is less than or equal to -3. The middle one is very clearly a -4, and it's going between -1, not inclusive, to 2, inclusive. All right, and this last one real quick, the slope is down 1 over 2, and if you go down 1 over 2, down 1 over 2, you actually cross at a half which I had just the wrong sign there, but there it is. And that guy is going from 3 onward.